This is a lecture on 7-2, confidence intervals for the mean when sigma is unknown. So section 7-2 looks exactly the same as 7-1. We're inferencing about the mean, so we're going to predict the population mean according to the sample. The only difference between 7-1 is we are aware of the standard deviation of the population. In 7-2, the standard deviation of the population is unknown. We have to use the standard deviation of the sample. If we need to accommodate for this change, what we have to do is we have to make the interval a more conservative interval. So we are still using a normal distribution, except that is no longer a standard normal distribution, but something called a t-distribution. So the biggest difference between a t-distribution and a z-distribution is the variance. So the standard deviation, so the z-distribution, standard normal curve, has a mean of 0 and a standard deviation of 1. A t-distribution would go, maybe I can use a red or blue color, would go something like this. So this is your t-distribution. It is still normal, meaning the mean and the median will all fall in the same place. You still have the area under the curve is equaling to 1. You still have the bell shape. The difference is the standard deviation is no longer 1. In fact, it is greater than 1. So it varies more. It also depends on degree of freedom. So the t-distribution will approach a normal distribution with n going to infinity. So as n becomes large enough, the t-distribution becomes the z-distribution. So what we're doing is for each t-distribution, we have to find the degree of freedom. The degree of freedom is usually abbreviated as a df, and it is calculated by finding n minus 1. So the number in your sample minus 1, that's your degree of freedom. You will need this degree of freedom if you are interested in looking at the table in order to find the t values. The formula for our confidence interval, this is the beginning of my next example. Let me just move this a little bit. The formula for the confidence interval when sigma is unknown is you still have the x-bar, your point estimate, and then instead of a z-score, you need to find a t-score, and then instead of a sigma, you're going to take an s divided by the square root of n, and this is your boundary for the mean, the population mean. So, and then you take your point estimate, and then you add the error. With the degree of freedom at n minus 1. The assumptions are still a random sample and n is greater than or equal to 30 or approximately normal distribution. All right, so this is where my first example comes in. A random sample of high temperatures of 12 recent Thanksgiving days has an average of 42 degrees Fahrenheit. Assume the variable is normally distributed and the standard deviation of the sample temperature was 8 degrees. Find the 95% confidence interval of the population mean for the temperatures. Notice I will start highlighting necessary information. A random sample of 12, so they gave me an n is equal to 12. They gave me an average of 42. So that's the x-bar. Assume the variable is normally distributed, allows me to use the t-interval because the standard deviation of the sample, that's a big one, is 8. This is how you can tell that you're in a that you're using a t-distribution rather than the normal distribution, the standard normal distribution. So this is your S, which is at 8. And what we're looking for is we're looking for the 95% confidence. Now you're more than welcome to try this formula. It's very lovely looking. You do need to find a t. You can either use an inverse t function on your calculator, or you can open a book to a t table and be able to locate it there. What I'm going to do is I'm going to jump into a calculator, and on my next video we'll actually do a guide on the calculator, but for now I'm just talking through it. What you're interested in is, or the function that you need for this is under stats, go over to tests, go down to t-interval, if you push on the t-interval, you have either data or stats. In this one, they were giving me statistics. So I will choose stats. It's asking me for the x bar, which is 42. It's asking me for S now, which is the standard deviation of a sample, and an N, which is equal to 12. Then I need a 95% confidence interval and push calculate. It's going to take its time because the t-interval the calculator needs to regenerate a t-distribution according to the degree of freedom. What you want to write down is you want to write down the actual interval that you're, sorry, that's not a comma, that's a point. So 36.917, comma, 47.083. So this is the interval that my calculator spit out. What you also want to include is the degree of freedom, which is 12 minus 1, which is 11. Another piece of information that has to be included with every single problem in chapter 7, or pretty much everything that comes after this, is a sentence that includes the units and what it is that you just found. So you can usually start with phrases like with 95% confidence. The population mean. For the temperatures, on Thanksgiving Day. So you're basically copying the first sentence of the original problem. Is or should be is between, and then you can round. You don't have to round. In this case, you don't need to round because there is such a thing as 36.9 degrees. So you can just say it is between 36.197 degrees Fahrenheit and 47.083 degrees Fahrenheit. That should do it. I do have one more example in this book that gives you the similar information but using data button instead of a stats button. So a data represents a random sample of the number of home fires started by candles for the past several years. Find 99% confidence interval for the mean number of home fires started by candles each year. So what we need is we need to go into stats first and over to edit. Under edit, what you're doing is under L1, you will enter all of the numbers. So 5460, 5900, 6090, 6310, 7160, 8440, and 9930. The 7-2 is going to be easier to do just because the numbers tend to be smaller. A lot of these problems that are in the book do tend to be under 30. They just have to assume that the distribution is approximately normal, which they actually don't in this problem, but they're doing it anyway. The assumption has to be that the distribution has to be approximately normal. So we have to assume it in order for us to even do this. So after you've done this, quit the menu, go into stats, go over to tests, go down to TInterval, and when you push on this, instead of stats, you choose data. Now all your calculator is asking you, where is your list? By default, list should be L1. If you can't find it, it should be under second stats, which is list. You keep frequency at 1, and what do they need? They need 99% confidence. Notice that within the problem, they did not give me any information besides the data and the 99% confidence. So when I do the calculate button, it's going to take its time, and the first thing that it spits out is the actual interval, which is 4,785, 9,297.9, and everything else is the statistics. So interesting information that it found an average to be around 7,041.4. It found the standard deviation of the sample at 1,610.3. It also mentions that we have 7 items in our data. That means that the degree of freedom should be 7 minus 1, which is a 6. And then we can write down our sentence with 99% confidence. We can state that the population mean mean number of home fires started by candles each year is between, and then you just say, personally, I would round to the nearest integer because you cannot have half a fire. So between this many fires and this many fires. Based on the sample. Based on this sample. Please note that the sample is n is equal to 7. I've managed to organize only 7 years. If I have an n is equal to 7, my interval with 99% confidence is going to be very big because I really can't tell much when I organize a data of 7. I need 30, 50, 100, something a little over that, but with an n is equal to a 7, you're not going to get any nice numbers. It's somewhere between 4,700 and 9,200, so huge. This is just about the gist of 7-2, and in the next video I will show you how to do these two examples on the calculator.